Hello everyone. Today we are going to continue this topic of heat equation in one dimension. And today's question is an insulated rod of length L has its ends A and B maintained at 0 degrees Celsius and 100 degrees Celsius. That means temperature at A is 0 and temperature at B is 100 until steady state prevails. Okay. Then what we have done, we have reduced the temperature of B to 0 to 80 degrees Celsius and temperature of A to 20 degrees Celsius. Find the temperature function U of x. From the given statement, it is clear that it is a problem related to heat equation in one dimension. And what is the scenario for us today? The scenario for us is we have a rod. This is the rod. This is the length and A and B, and length is L. So initially temperature function at this one is 0 degrees Celsius and over B it is 100 degrees Celsius. Then steady state conditions prevails, and after steady state we have steady state. Then we have temperature at A as 20 degrees Celsius and temperature at B is 80 degrees Celsius. That means we have lowered the temperature at B and raised the temperature at A. Okay. So the above statement problem relates to one dimension heat, or you can say diffusion equation such that curly to u by curly x square is equal to 1 by c square curly u by curly t. Let be equation number 1. The possible and compatible solution for given boundary conditions is u of xt is equal to c1 cos of px plus c2 sine of px into c3 e raised to minus of c square p square and t. That is your equation number 2. Now if I look at the given boundary conditions, we have these two values which are non-zeros. Okay, since the given boundary conditions are non-zero, therefore the required result consists of two parts. Okay, which two parts? Number one, that will be steady state, which is written as us of x, and number two, transient state, which is ut of x. Okay, now therefore u of xt, final u of xt will be equal to u of sx plus ut of xt, and that is your equation number 3. Now for initial temperature distribution, that means at time t equal to 0, ut of x. Now for initial conditions, what was the temperature? 0 and 100. So temperature at end A plus temperature at end B minus temperature at end A over the length of the rod into displacement, that is equal to 100x by 5. That will be your equation number 4. And for final temperature distribution, that is us of x, that will be equal to temperature at and A. Now, after steady state, we have 20 and 80. So that means 20 plus 80 minus of 20 over L into x. So it will be 20 plus 60x by L. That will be equation number 5. Now what we have to do, we have to substitute the value of equation number 5 and equation number 2 in third. So substituting values of equation 2 and 5 in equation number 3. So u of xt will be equal to 20 plus 60 x by L plus C1 cos of px plus C2 sin of px into C3 e raised from minus of c square p square t. Okay, let it be equation number 6 now. Now we have to apply the boundary conditions one by one. Okay, so for the first boundary condition, that is at x is equal to 0. So when x is equal to 0, what is the boundary condition given to us? That is 20. U is equal to 20. So u is equal to 20. So 20 is equal to 20 plus 0 plus c1 cos 01 plus c2 sin 00 into e raised c3 e raised to minus of c square p square and t. So 20 is equal to 20 plus c1. So from this one we get c1 is equal to 0. Okay. Now I need to substitute the value of c1 in equation number 6. So equation number 6 reduces to u of xt is equal to 20 plus 60 x by L plus c2 c3 sin of px into e raised to minus of c square p square and t. Let this will be your equation number 7. Next boundary condition, at x is equal to L. Now the value of u was 80. That was 80. So 80 is equal to 20 plus, if I substitute L and L cancel out, that will be 60 plus C2 C3 sin of PL e raised to power minus of C square P square and T. So it will be 80 is equal to 80 plus C2 C3 sin of PL into e raised to minus of C square P square T. From this one we get 80 minus of 80 is equal to C2 C3 sin of PL into e raised to power minus of C square P square and T. Okay. Now that will be C0 is equal to C2 C3 sin of PL, because this is dependent upon T, not on X, so we can remove this one. So from this part we get C2 C3 cannot be 0. We have only the value of sin of PL is equal to 0. That is PL is equal to n pi, or we can say P is equal to n pi by L. Now I need to substitute the value of P is equal to n pi by L in equation number 7. So 7 reduces to u of xt is equal to 20 plus 60x by L, 20 plus 60x by L plus C2 C3, that is what? That is summation Bn. Okay. Sin of n pi x by L into e raised to power minus of c square n square pi square over L square into t, and that is what? That is our equation number 8. Now we know that at time t equal to 0, u was 100x by L. That was equation number 4. 100x by L. 100x by L. So I need to apply this condition on equation number 8. So equation 8 reduces to 100x by L is equal to 20 plus 60 x by L plus summation Bn sin of n pi x by L into e raised to power 0. So 100x by L minus of 20 minus of 60x by L is equal to summation Bn sin of n pi x by L. So 100 minus of 60, that is 40x by L minus of 20 is equal to summation Bn sine of n pi x by n. Now value of Bn can be find or evaluated by using Euler's formula of Fourier series. That will be Bn is equal to 2 by length of the rod, 0 to length of the rod, 40x by L minus of 20 into this function sine of n pi x by L into d of x. Okay. Now we are going to apply u into v form. So first function as it is 40x by L minus of 20 into integration of this part sine. So integration of sine will be minus of cos n pi x by L over n pi by L minus, now derivative of this part. So 40x by L will be 40 by L. Integration of this one minus as it is, integration of cos will be sine of n pi x by L over n pi by L. And 1 pi n pi by L is already there, so it will be n square pi square over L square plus derivative of this one, that will be 0, so no need to further solve it. 0 to L will be close. So 2 by L, now 40x by L minus of 20 into L over n pi with negative sign into cos of n pi x by L. Minus and minus plus 40 by L into L square over n square pi square into sine of n pi x by L within the limits 0 to 1. Now upper limit minus lower limit. 2 by L. If I substitute upper limit L, L and L cancel out. So 40 minus of 20, that is 20, minus 20 L over n pi into L. If I substitute over here, L and L cancel out. Cos n pi, that is minus 1 raised to power n, plus 1 L and L cancel out. So 40 L over n square pi square. Sine of n pi, that will be 0. That is the upper limit minus lower limit 0. 40 into 0, 0. 0 minus of 20 minus 20 and minus L, so it will be positive 20 L over n pi. Cos 0 will be 1 plus sine 0 will be 0. So this step will reduce to 2 by L minus 20 L over n pi minus 1 raised to power n minus 20 L over n pi. Now I can take minus 20 over minus 20 L over n pi as common. So I'll left with this part. So it will be minus 40 L and L cancel out over n pi into minus 1 raised to n plus 1. Now here we have a category that what is the value of n? Now if n is even, that is minus 1 raised to 2. So it will be minus 1 scale will be 1, 1 plus 1, 2. So it will be minus of 80 over n pi. And what is the case if n is odd? If n is odd, that is minus 1 raised to 1. So minus 1 plus 1, 0. So this will be the values of Bn depending upon the value of n, whether it is even or odd. So I need to substitute in equation. Now in which equation we will substitute? We will substitute in equation number 8. Substituting this value in equation number 8. So u of xt will be equal to 20 plus 60x by L plus summation n for even only. Okay, for even, that will be minus of 80 over n pi into sine of n pi x by L e raised to power minus of c square n square pi square over L square into t. Now we can take constant terms outside the summation series. Minus 80 over pi summation n is equal to even 1 over n into sine of n pi x by L e raised to power minus of c square n square pi square t over L square. Now this is a required solution. Now in some books whatever they have done, they have converted this n is equal to even into general term. For that, what we have to do, we have to substitute the value of n is equal to 2n. We have to just replace 2m or 2l, 2p. That will be the only the solution. Okay. So that is the result, which is the required solution of heat distribution function. I hope the concept is clear to everyone. Thanks. Goodbye.